Question number 9 on mixing a certain alkane with chlorine and irradiating it with ultraviolet rays, it forms only one monochloroalkane. The alkane could be A. pentane, B. isopentane, C. neopentane, and D. propane. Now, for example, let's take into consideration of a simple pentane. Okay, so here, when we take into consideration of pentane, CH3, CH2, 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 and CH3. This is the N-pentane, 1, 2, 3, 4, 5 carbon systems, right? So now this one, once we treat this one with chlorine, right? So chlorine under the presence of sunlight, or that is ultraviolet radiation in this case. Now, first thing that we need to know is chlorine, when it undergoes the reaction, it first undergoes an homolytic cleavage in order to give us 2 chlorine free radical. So hence the entire process, as what we know, is going to be of the free radical mechanism. So here in this entire scenario, the chlorine radicals are going to react. Okay, it will react with these particular carbons. Now, when it reacts with the first carbon or the last carbon, it's going to be the same in this scenario. So therefore, we are going to get over here CH3, CH2, 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 1, 2, 3, 4, 5. So CH2Cl. This is one possibility. Second possibility for this one is with respect to CH3, CH2, CH2, CH, 1, 2, 3, 4, and this is the second possibility. So it is not giving me one compound, rather it gives me more than one compound over here. Okay, in the next scenario, it will attack in the center one. Okay, so it is going to attack to the center one, something like this. So CH3, CH2, so CHCl here, CH2, CH3. So 1, 2, 3, 4, 5. Okay, so here this thing is going to give me 3 types of monochloroalkane. So therefore, this is not an answer. Okay, so when we take into consideration of an isopentane, okay, so isopentane, in a sense that we are going to have over here CH3, C, CH3, H, CH2, CH3. So 1, 2, 3, 4, 5. Okay, so now once we have this and it reacts with chlorine. So the moment it starts reacting with chlorine, Cl2 under the presence of H nu. Now here, there are possibilities that this carbon can react. So if that carbon is going to react, then we are going to have it as CH3, CH3 here, H, CH2, CH2Cl. This is one particular condition, right? So now, let's say second carbon is going to be under attack. So that time we are going to have it as CH3, CH, CH3, CH, Cl, CH3. Now, second possibility is that this particular carbon, that is this carbon, can be under attack. So that time we are going to get it as CH3, C, Cl, CH3, CH2, CH3. Next time, there is a possibility that even this particular carbon, one out of these 2 carbons, whether I attack over here or whether I attack over here, both of them are going to be same. Okay, so that time we are going to get it over here as CH3, CH2, Cl, CH, CH2, CH3. Okay, so again, even this one is going to give us more than one monochloroalkane. But when we observe about the neopentane series, so for a neopentane, let's take it over here. Let's take the neopentane over here. Okay, so when we speak about the neopentane, it is going to be like CH3, C, CH3, and CH3 here, and CH3 here. This is a neopentane. So here, whether I take into consideration of this particular carbons, hydrogen, this one, or even this one. All these particular hydrogens are same. Whether I replace any one of these are going to be same. So when it undergoes a reaction, over here, under the presence of chlorine and H nu. So here what is going to happen is one of these hydrogens is going to be replaced. So therefore it gives us Cl. So CH3, CH3, and finally here CH3. Okay, so this is going to give me only one type of product, and hence our answer is neopentane in this case.